So we'll now continue with the next part of our seminar. So thank you for returning on time. So let's give an applause to Mr. Ngu again. So for this session, he'll be presenting about BIM between MiTS and Civil 3D.
Alright, so I guess at least 80% of you are already here, right? Those who are not yet here, can you raise your hand? Those who are not yet here, can you raise your hand? Right, okay, great. I think most of you are already here. Okay, since most of you are already here, just before I start my presentation on this BIM thingy, there is one thing I think is too good to pass out. I really need to show this one to you guys. Okay, so this is about MiTS program. Nothing to do with BIM, but then it's something to do with our 3D view and clash analysis. Okay, this is, I think, it's quite good, which I really like this feature. So I have to share with you the toys. Okay, alright. So basically, this is this is a feature that we implemented in the 3D view and also in the clash analysis. So basically, I just want to show you how you can actually verify that the results are consistent now. Okay. Okay, right. So basically, this is a project here. Okay, we have this project, and then we have some utilities, some network pipes, and some network structures. So now the important point of this one is that, okay, now I want to do an analysis. I want to show you how you can actually cross-check the dimensions, especially the clashing distance between different pipes or different pipes and structures. Okay, I want to show you how we can make everything measure everything consistently. This is a little known features, so just allow me take a bit of time to display to you guys up. Okay, alright. So this is what you saw just now in the 3D view. You saw that we can actually see the layout, the overlay, right? Whether the design is pass or fail, whether the clash is pass or fail, and stuff like that. Okay. Now I want to show you how you can actually do the comparison. Right. So here we have this 3D views, then we can do a clash analysis. This is how the clash analysis looks like. But let me just put this two different sides here. All right. Okay. So let me just turn off all the terrain thingy. All right. We just maintain with our networks. All right. Okay. So now here, if you are inside this clash analysis, this one will tell you what is actually going on here. We have a warning sign here. All right. So you can actually click on the warning sign. It brings you to exactly what is wrong with this guy here, right? So as you can see here, when you click, and it is this one here, right? Number one, ID number one, all right? So it is 1, all right? So this one, it has a clearance of 0.486, which is not really sufficient, apparently, according to this software. So we can actually check whether this 0.486 is really consistent or not. This is our entity here, manhole, and then clash with the water pipes is the water pipe. So we measured the water pipes and the manhole. So let's just try to measure. You go to CAD, measure. We take the point. Yeah. Oops. So we cannot see. Too bad. We just measure right again. 0.488, about there, okay? Because maybe my hands are not precise enough to get the most minimum distance. But you can actually verify that to satisfy your curiosity that they are actually consistent, right? So another thing that I find it very good is that it actually links to the 3D view. Yeah, see, when there are so many pipes and structures, sometimes you just don't know which one is clashing. But then, for the 3D view, then it tells you where it is clashing between this particular sewer and also this water pipe, right? Alright, so let's try to measure them once again. You can actually measure this 3D thing. Right? Do the distance measurement in 3D. Go to this measure 3D. Select this guy here, the manhole, and also this guy here, the water pipes. So it does the measurement 0.486. You see, this is exactly as what we saw here. So this is how we verify that everything is consistent, okay? And okay, let's try another guy. Okay, then this one here, we have this clash here, all right? So exactly how does it crash? So we right click, long section. Okay, so it says 15 here. So as you can see here, this water pipe is located right at, okay, at is the correct word, right at the sun there, you see? So this is why it is a hard clash, all right? So you see the red thing here. So let's see, 3D view. So, okay, this shows you exactly what went wrong, you see? So can we just measure them? Oh, I don't want you. I just measure them, okay. Oh, can I rotate? Yeah. So you can see that it seems to be clashing, but let's just to confirm once again. See? So you can see that the pipes and the drains and this guy here, the sum, they are all clashing, alright? So this is the features that are little known, but it's actually very handy, especially when you want to do the clash checking, right? Because everything you can do it in a single interface, and then you can just click and then go to the clash point, and then later you want to do the resolution if you want to, right? The 3D view as Amber have shown you this morning. All right, okay, so that's it for my this extra presentation. All right, so now we go to the BIM thingy. All right, to make sure that everyone is not sleeping. Well, I try to make my presentation interesting, and to make sure that your colleagues are not sleeping, if you have questions, you please raise your hand and ask, okay? Alright, okay, so anyway, this presentation will be interlaced with demo, right, throughout, so it will not be a very long slides presentation, which I think will be very boring, right? So I try to make this presentation as interesting as possible, and I hope that we can have an interactive section, all right? Interactive sections. So since most of you, if not all of you, are going to do BIM or already done BIM, so yeah, so our interaction here, the feedback here will actually help us both, and yes, also you guys and your colleagues a lot. Okay, let's see how we can move towards this BIM thing as a nation and as a profession. Okay, so. Yeah, like how Brian mentioned, we are at the forefront of this BIM thing. Actually, JKR approached us some 6 years ago when they talk about this BIM, right? They said, "Oh, can you do the BIM for us, right? Can you do the BIM for us?" Then at that time we were a bit naive, all right? So we thought that BIM it's all about open standard exchange, right? IFC files, right? IFC files in the ISO. Everyone can read and write, okay? But then, we learned that they were actually talking about different things. They were talking about civil 3D integration, right? And the integration between civil 3D and MiTS is what they call BIM. And I think this actually governs the philosophy of JKR and BIM industry by and large. In Malaysia and maybe also in other countries. Maybe in some other country like Europe, they will have placed more emphasis on this open BIM thing, right? They will more like to centralize everything on this IFC file, which is an ISO standard, which is actually passable by everyone, which is actually open, yeah? When you right click and open an IFC file in Notepad, you can actually see exactly what is going on inside. I'm not too sure whether you have taken a dip into it or not. It's actually very fascinating. It is the IFC file itself is written in pure, numbers, pure English. All right, so this is what makes it open. But by contrast, Civil 3D comes in the form of DWG format, which is not passable by anyone except Autodesk. You can try to open it in Notepad, but then it will be all gibberish to you and to me because it is written in what we call binary format. All right, so we and probably a lot of people out there will really like that the BIM thing is actually centered around a center format. Like I say, alas, this is not the reality we inherit. Instead, we get DWG format, okay, which we cannot easily pass. Okay, but then we still have ways out, still have APIs, and this is how we can actually write to Civil 3D. Okay, so like I said, this is the idea of BIM, building information management. Yeah, you want to have everything, different softwares talking to each other. All right, if one software vendor go kaput one day, then we still have data saved in other software format. You don't have to be worried, oh, I buy this software, then afterwards this software bankrupt, then oh, my file cannot be read. BIM, one of the objectives of BIM is to actually solve this problem. You put everything in a centralized place, the file formats are accessible, all right, so that everyone can sort of like, in a very general sense, open your file, right, regardless of, whether they're using the same software for you or not. Okay, all right, so this is the ideal of BIM. Now, say on my right hand side, the ideal of BIM. On your left hand side, yeah, it's on your left hand side. Right, everyone centered around IFC. You have Revit, you have robot, you have MiTS, you have Bentley, you have whoever. Everyone is talking to each other through this one central format. That's the ideal. All right, but the reality is that everyone is centered around Autodesk nowadays. All right. Here I'm not trying to pass judgment on whether this is good or bad, but this is just a reality. Alright. Oh, as a side note, yeah, maybe you find that, how come this symbol here, the rabbit, has a wrong symbol, it is a class symbol, right? Maybe, I don't know whether you notice this or not, this thing here. Right? This is not rabbit symbol, I think this is class symbol. Okay, let me just let you on the confession now, okay? I generate all these things using ChatGPT. Alright. I try to prompt this image multiple times, try to express my concept, but then this is the best that it can give me. Alright. So yeah, just as a side note, AI is good, but then it looks correct. It looks correct, but then sometimes you just cannot get it exactly correct. Alright. So which is why I'm actually a bit reluctant to pass AI, the keyword AI over all of my software. Right? I don't want to say, okay, this is AI Silverage, AI Drain, and stuff like that. Yeah, because to me, when we come to engineering design, we want exact, repeatable steps. Everything must be correct and must be explainable, must be transparent. But the current AI, as we know it, the LLM, the ChatGPT, and all those things, they are not explainable. They are not transparent. You can get it to do something, but then sometimes they give you things like this. So I hope that you can forgive my, this wrong diagram. Anyway, I think you understand the concepts. Okay. All right. Okay. So I don't know how many of you have seen this kind of tables, right? Okay. This is basically some tender documents that we got from JKR, right? So basically, JKR actually have a detailed specification like, okay, for earthwork, what are the things that you need to submit, all right? You need to submit things like, okay, you have this earthwork objects, which is in EG surface, design surface, all right? Then for this, and then we go on and then we design corridors, and then you need to have all this cut and volume calculation, section and cross section. This one maybe we all understand, but you need to have this also here, object styles, label styles, and table styles. All right. So this is for earthwork. For this road, then we need to have surface, corridors, feature lines, road furniture marking, blah blah blah, everything, and also you need to have appropriate object styles, label styles, and table styles. All right. And similarly, for drainage and water reticulation, or we call gravity networks and pressure networks, you also need to submit all these things in the DWG file. Corridor, pipe networks, sub tables, cover tables, of course again, object styles, label styles, and table styles. And then you have these pressure networks, network tables, and of course the object styles, label styles, and table styles, all these things. Now, all these are actually Civil 3D terminology, right? All these are actually Civil 3D terminology. So, so actually, the Civil 3D file that the JKR requires, or the BIM submission requirement, is not only AutoCAD drawing, right? AutoCAD drawing and Civil 3D drawing, they are actually Well, different things. Civil 3D is actually like a higher level than AutoCAD drawing, all right? Because in Civil 3D, we have all these so-called civil objects, not just your simple lines, points, maybe polymesh. No, we have in Civil 3D, we have more than that. We have tables, we have stars instead of layers, we have stars, all right? And then we have tables, all right? And for the pipes, you don't just see a single line or two lines of pipes because there's, well, doesn't convey too much information, all right? We need to have these pipe networks in Civil 3D, okay? So as we actually try to build our interface with Civil 3D, we come to actually grasp with all these terms, all right? And then we try to actually create such a Civil 3D drawing in the fulfillment of all these requirements, So later, we will show to you how we can actually do all these things, yeah? How we can do all these things. So then, that means that you don't even need to actually know how to actually create a sum table, for example, in Civil 3D. You don't have to actually know the internal commands because we can provide, generate such a thing for you, all right? Right from the MC integrator, right? So, how many of you have seen this thing before? Can you raise your hand? Never seen before. Any of you bid for JKR projects? Well, I thought some of you at least have the experience of going through a few BIM requirements. Surely you have seen this? No? Yes, yeah, okay, right. So, yeah, so mastering all these things are actually another level than mastering the usual CAD commands, I would say, alright? Okay. So, any questions? No questions. I hope that you're not sleeping, huh? Alright, okay, so like I said, we have to master the BIM. There are a few ways. One is that you attend courses. I know that CIDB actually offers courses on this. It's like a 3 days or 4 day course, costs around 1,400 for Civil 3D. Right? That kind of price, they're looking at that kind of price. And it's a one-time thing, all right? So you learn it, so better you go back and practice it. If you forget it next time, then you have to, re-study it again, right? That's one way. You attend course and then you practice on it. The other way is that you self-study. Well, actually we did a lot of studying on this, which is why we have this website here called Civil Wiz. I actually spent quite a lot of time studying all these things, and then I wrote all my study notes, so-called study notes here. All right, okay. So as you can see here, so these are all the notes that I put forward. It's also inside the link here. You can later go back and then browse through. Okay, so the purpose of this one is to actually, first and foremost, is actually to help me myself learn Civil 3D. Alright, so after I learn it, then okay, I feel that I need to share it with everyone. And also, sharing it with everyone is the best way to teach, right? To learn. To teach is the best way to learn. So that's what I did. So you can see how many things I wrote. Yeah, so this is the complexity of Civil 3D. Okay, and then not only that, in our blog post, in our blog post, we in our user guide, we also have a lot of this user guide, okay, pertaining, right? So, for example, this one here. Let's click on this one. Okay, this is how we actually do our integration, right, with Civil 3D. All right, so we actually documented our findings, and then we actually put forth the learning outcome here. All right. So as you can see here, we have all these things like wall break lines, boundaries. Yeah. So the idea is that when we create this Civil 3D the MC integrator, we will actually try to sync it not only at the CAD level, but also at the Civil Sync level, at the level where the BIM requirement actually requires. All right. So you can go through it. It's a bit technical. All right. So yeah, it takes a while to get used to it, but then I'm not going to go through it here. All right. So here are a few links. Okay, we actually document how we actually do all those synchronization and how we actually work with Civil 3D. All right. So that when you use our software or you use our this plugin, you will also understand what is going on if you really want to. All right, you can understand that, convince yourself that, okay, what we are saying, what we are doing is actually correct, okay? All right? So, like I said, mastering BIM, there are two ways out. One is that you attend the course and make sure that you keep on using it, all right? The other way is that you study, you spend your time studying. Okay, but for the first way, if you attend the course, then you have to make sure your colleagues also attending the course, right? Because maybe one day you leave the company, but then the company will have to get another guy to go and to study, pay another 1,200 again. Okay, so this is the thing with the knowledge. Okay, it is not easily transferable. It's not easily transferable. So now we are thinking, is there any way that we can help people with that? All right. And our answer to that is that we will have an NC integrated solution. So the idea is that you only need to know one software, right? Our MiTS software, and then we will actually sync or transfer all the necessary data at the correct level of abstraction to Civil 3D, all right? If it should be a table object, then it will be a table object. If it should be a star object, then it will not just be a layer, right? If it should be a surface, then it will not be a polymesh, all right? That's the whole thing, all right? That's the whole idea. Okay, so far any questions? Yes? Sorry, my friend, can you give him a microphone? I don't want you to shout.
Hello. Can I say MiTS 3.0 is a design software that has a function that will generate a BIM requirement output, so that if I have a project with JKR, I need to fulfill the BIM requirement. I don't have a BIM modeler in my company, so if I have it, I can design it, and I can make sure it's correct, and I can generate the output to the Civil 3D using the MC integrator. So I will have output that fulfills the BIM requirement. Is that correct?
Thank you for your question. This is a very good question. And I need to answer that you are 100% correct, right? Actually, this is the goal of our MC integrator, and what has been occupying us for past some years, all right? Because we really understand that, okay, mastering Civil 3D is not easy. And then now with this BIM requirement coming in, you really have to like model two places. It's very, very annoying, very, very tedious, and it is very error prone. That's why we want to have these things. We want to build in this feature so that you just have to model it once, okay? I'll talk more about this, okay, later. But anyway, thank you very much for your question. That's the conclusion. All right, any more questions? No more questions. Or perhaps you actually know more than I do. Maybe in that case I can retire and we can go home earlier. Right, no more questions. Then shall we continue? Thank you so much. All right, oh yeah, okay. Yeah, that's what our gentleman here said. Our idea is that we want to model it once only. Right? If you model in MiTS, you do not have to know anything about swap parts. Anyone of you know what is swap parts? Swap parts. Yes, you know? Okay, that's good. You do not have to know about swap parts, okay? Right? And you do not have to know about band sets. Anyone know what is band sets? Civil 3D terminology, alright? You do not have to know anything about, let me find the difference between standard break lines and wall break lines. What are they? What's the difference? Well, if you, yeah, well, BIM modeler is supposed to know all these things, but we want to make sure that you do not have to know all these things, and yet you still can fulfill your this BIM requirement. All right. Model ones export everywhere. Change in Civil 3D. Auto Magic update in MiTS, and vice versa. Auto Magic is actually a word. It is not a misspelling. All right. So I want to make this thing like it's automatic and it's appearing like magic. Okay. All right. So no Civil 3D knowledge beyond MC Integrator. All right. You will see how it looks like later on. All right. So basically, you just have to. Well, you still have to learn Civil 3D lah. At least learn the MC Integrator part lah. Okay. But then it will be just a few buttons and it will be properly explained. So it's a lot easier than only about Civil 3D things like catalogs, part catalogs. Anyone of you know what is part catalogs? Pressure catalogs, network catalogs and stuff like that? Yeah, well, we try to make sure that you do not have to know these things, okay? And fourth point is very interesting. Yeah, we want to make sure that the Civil 3D is free for you. I think by now everyone is waking up. It's free for you. Of course, with some string attached, and there are some nuance to it. But we will get to that point later, okay? Alright, so far, any questions? Okay, if no questions, then let's see what is the next thing. Okay, yeah, demo time. I would like to pass my time to my colleague, Miss Patricia, and then she will show us how this MC integrator thing works. Right.
Hi, good afternoon everyone. Are you guys ready to see, I would say like a longer demo than previous on the integration between MiTS and Civil 3D? Okay, so basically for this demo session, it will show to you full integration between MiTS file and also Civil 3D. Okay, so this demo, it will be based on this MiTS sample file here. So as you can see, we already designed this earthwork, roads, and also utilities. Okay, and then another file that we need is definitely the drawing file, the Civil 3D drawing file. So in this case, this drawing file, we have set up a proper network catalog and also part list, okay, which you can view under this mesh tab directly. So how we can get this mesh tab is basically from the MC Integrator plugin that we must provide for you lah. Okay, so over here we have this machine button. So if we click on I understand, continue, the interface is very much, I would say, straightforward. Okay, so you can see this is where you'll be able to set your network catalog and also part list. Now, because this demo session, I would say I don't really have much time to explain step by step, so we will start right away with the sync process lah. Okay, so to start the sync, I will click on this load from MiTS button. And then as you can see on the screen, this project parameter definition will appear. So basically for this demo session, I have already predefined the parameters, whereby the survey data and platforms, including slopes in MiTS, will be integrated into Civil 3D as surfaces. And then this road will be seen as corridor and corridor surface. And then the utility pipes, they will be seen as civil objects. Okay, so now I click on this OK button here, and the sync process already started. Okay, so this may require some time on your end lah, but this is not because your software is hanging or anything. If you take a look at the bottom part here, you'll see that the software is actually doing the modeling for you. Okay, it starts with the surfaces and then also on the road and also on the utilities simultaneously. Alright, so when the interface looks like this, that means your scene already finished. So we click OK here, and then we close this action panel. There is this verification panel. It works similar to MiTS, whereby it gives you a list of warnings and errors related to your scene. And then we also provide you the message, suggestion, and we also linked all this message to help you to go to our article where we provide you the step-by-step on how to resolve all these issues. So we close this verification panel. So let me zoom in real close. You'll be able to see these are the synced entities. So if we take a closer look here, it looks similar. It looks identical to the input plan in MiTS. Okay, let me just show you one more time. This is how the input plan in MiTS will look like. And for the sync entities, we can also compare it in 3D model. So let's say I just select all these sync entities here, and then I use this object viewer in Civil 3D. And then, okay, the style here is set to conceptual, and then I change the orientation. So this is how the 3D model looked like in Civil 3D. Now, let us compare with the 3D view in MiTS. So I have generated the 3D view based on our design. Okay, as you can see, it looked quite similar. Okay, and then we don't only compare on the 3D model, but now we will also do some, I would say, like a benchmarking lah. Okay, whereby we compare the integrated data between MiTS and Civil 3D. So in this case, let's start with the first synced entity, which is the surfaces lah. Okay, so I close on the object viewer here. Hold on, let me close back this action panel. So in Civil 3D, at the left side prospector tab here, there will be a list of all the sync entities from MiTS. Okay, whereby you can see there are lists of surfaces, and then there's also corridors. And then if you expand these pipe networks, you'll be able to see the gravity networks, which represents the sewerage and drainage. And then we also have these pressure networks for water reticulation. Okay, so let's start with the cross-checking for OGL surface. Okay, for these surfaces, if it come up with this icon, it means that there are items out of date. So let me just rebuild that one. And then let me close the action tab. Okay, this OGL surface, it basically represents the survey data in MiTS. Okay, now to do the comparison easily, I will also change the surface style over here, so that it can look similar to the one in MiTS input plan, okay, whereby each elevation will be represented by points. Okay, now in Civil 3D, to read the elevation, we will use this coordinate tracker under this palettes section here. So we set the surface to OGL. Now I move my cursor and select one of the point. Let's say I set to this particular point here. Okay. Okay, so the red elevation, the red elevation here is somewhere around 25.95 if I'm not mistaken. Let me just, okay, the elevation here is 25.950 meter. And then if we go into MiTS, okay, we go to the input plan, main, edit button of the survey points. Let's select the similar survey point to just now. So as you can see, the Z elevation is indeed 25.95 meter. Okay, we can also do the same checking for the platform. Okay, for example, let's say I go to earthwork input, click on this edit button, and I select this particular platform here. The elevation is 29 meter. So if I go into Civil 3D, we will use the same feature here, which is the coordinate tracker, just that we need to identify and select the correct surface. So this mesh PLT slope represents the platform and slope in MiTS. Okay, so we click on this. And now let's move, or let's hover our cursor on top of the same platform here. As you can see, the Z elevation red is indeed 29 meter. Okay, so basically that is how we compare on the surfaces. Now let's move to the next entity, which is the road. Okay, for road, in Civil 3D, the surface is represented by this corridor surface road datum. And this is modeled based on the corridor here. The corridor here is basically the model of the road design in MiTS. Okay, so if we expand this corridor, and let's say I click on this MiTS road corridor, we can see the horizontal and vertical baseline. This is basically, I would say, similar to the horizontal and vertical alignment in MiTS. And if we click on this main road, you can see this is the centerline alignment applied in this particular main road. And then if we go into the MiTS software here, and then I go to this main tab and click on the road module, and then I double click on this main road, you can see the same centerline alignment. Okay, and then not only that, if we go into Civil 3D, for this particular MiTS road corridor, if we expand and click on one of the baseline, for example this main road baseline here, it will list out the assembly. So this assembly is equivalent to the MiTS road width. Okay, basically where we design what are the road offsets for our design lah. Okay, so let's say we try to find these assemblies over here. Okay, this main road both, and then I would zoom into this particular assembly. As you can see, each side of the road are designed with 2 carriageway and a shoulder. Okay, and if we go into MiTS, go to the road width, For the main road, if we go to the spread input, we'll be able to see each of the master string side. We will have 2 carriageway and a shoulder as well. Okay, and then not only that, with the road synced as corridor, okay, we will also have the road output synced into Civil 3D as well. I would say not really synced, but the Civil 3D will use the corridor and generate the road output. So we have this super elevation diagram. If we take a look at the second curve here, you can see the crossfall here is 5.96%, and if we go into MiTS, we can compare this with the vertical detailing. So over here we have the super elevation, and if we go into the second curve here, you can see the crossfall is indeed 5.96%. Okay, not only that, we can also compare on the horizontal and vertical profile. For example, the horizontal profile, this is the length, and then let's say for the vertical alignment here, I take this length as a sample, 79.773 meter. And then if we go into MiTS, we can take, we can zoom out a bit, and then there will be the horizontal and vertical profile, whereby the length, this plate will be identical to the one in MiTS. Okay, as you can see here, this is the length, and then this is also the length for the vertical, which is 79.77 meter as well. And then we also have cross sections generated in Civil 3D, and we can also compare this. Okay, let's say we take this 175 as an example. So this is how the cross section is generated in Civil 3D, and we can compare it with the same cross section as in MiTS. So let's say for the main road, I change the chainage to 175. You can see the cross section will look similar. Okay, and for earthwork and also road, not only we compare on the 3D model or on the generated output, the most important thing is the volume lah. Okay, so for the volume here, okay, I'll show you based on the slides, okay, where we compare for both earthwork and also road. Okay, so for earthwork cut and fill, the volume comparison, as per, I think this one is already shown previously by Mr. Ngu, okay, whereby we can see over here, it compares our platforms to the thin surface created in Civil 3D. The cut and fill volume are quite similar to one another with discrepancy less than 1%. As for the road, okay, it will use this road end area method. These two methods are applied in both MiTS and Civil 3D. So we take chainage 175 as an example. So the MiTS volume is 4525.05, while the volume in Civil 3D is 4523.04. So as you can see, the discrepancy here is indeed less than 1%. Now, we move to the next one, which is the utility. We go to this, for example, the pipe networks here. Let's say I select this particular sewer network, okay, and then I select all. Okay, we can also compare with the object viewer. Okay, let's say I change the style here to shade it with edges, and then I change the orientation. So this is how the sewer network look like in Civil 3D. And then if we go into MiTS software, okay, we go to the 3D view. Let's say I toggle the entity and then turn off the unrelated design. Okay, sorry. Okay, as you can see, the sewer network that appear will look identical to the one in Civil 3D. So now for utility, we will compare important information such as the invert levels, pipe length, pipe diameter, and so on. Let's say I take an example for sewer model here. Okay, let's take this sewer 10 as an example. Okay, so the invert level rate for sewer pipe 10 is 26.05 meter, and also the end invert level is 25.766 meter. Now if I go into Civil 3D, okay, I expand this sewer and I click on the pipes. Okay, let's say I select this particular pipe and show the pipe properties. So you can see the start invert elevation and the end invert elevation will display the same value. Okay, and if we scroll down, we can also see that this particular pipe is made of reinforced concrete with the inner pipe diameter of 225 mm. And if we go back into MiTS, we can see that the pipe here is 225 mm. Okay, and then and then this pipe description is HDPE pipe. Okay, so this is also similar to the pipe type here, which is the HDPE. Alright, and then while the synchronization happened between MiTS and Civil 3D, as you can see, the other design properties are still maintained. For example, the PE value here are still maintained as what we have designed in MiTS lah. Okay, not only on the pipe, okay, for all the node or the manhole design, in MiTS, it will also be seen as structures in Civil 3D. Let's say I take this node 3 as an example. The ground level here is 27.250 meter. So this ground level is very important to make sure the depth of the structure is correct in Civil 3D. Now if I go into Civil 3D, I close the pipe properties, and then let's say I click on the structures here and then go for the structure 3 properties, and then we'll be able to see the surface elevation at insertion point is indeed 27.25 meter. Same goes with the main hole design, in which this one has an inner diameter of 1500 mm. If we go into Civil 3D, we'll be able to see it is designed with as a cylinder node with a profile of inner diameter 1500 mm. Okay, the same goes for the other utility. For example, the storm sink. Let's say I take open drain here, which is drain 3 as an example. With the limitation in Civil 3D, okay, it cannot cater for open drain. So typically for synchronization, we will advise you to use I would say a closed rectangle or square shaped drain. Okay, as an example, let me show you. Okay, I expand this drainage and I click on the pipes here, and then this is pipe 3. So as you can see, it is being seen as this concrete box culvert. Even though they are seen of a different, I would say different drain type, if we go to the pipe properties, you can see here the start and end invert elevation will still be maintained. This is the value 25.552 and 24.480. If we go into MiTS, we can see this invert levels is exactly the same. Okay, and then let's say we make some changes to the Civil 3D network. Okay, let me show you. Let's say I select drain 7 here. From a 900 mm concrete pipe, I try to swap the size. Okay, I try to swap part basically by changing the size to, let's say, 1050 mm concrete pipe, and then I click OK. And then let's say I do the same changes to one of the sewer pipe. Let's say we take this sewer pipe 10 and then change the size. Let me reselect back. Okay, let's say I swap the part to a different size, let's say 400 mm, and then I click OK. Now I can already start to sync back into MiTS. But before that, let me just close this project file first. Okay, and then we go to the Civil 3D. You just go to the Mesh tab here and click on this Sync to MiTS button. Okay, for surface, platform and road, I would suggest you to just change it to no sync so that you will not affect your existing platforms in MiTS lah. Okay, so let's say I just change the sync mode here to no sync. Same goes with platform here, no sync, and road as well, no sync. And then I click OK. For the utility pipes, you don't have to make any changes. Okay, we just click OK and then we wait for the software to finish the synchronization. So basically, now this display that the sync is already finished. We click OK. We just go to MiTS and then we open back the same project file. Okay, if I go to the storm sync module, okay, and then I look for this, I look for the drain 7. Okay, you can see now the pipe diameter has already been changed to 1050 mm. And then if we go into the main tab and then go to the sewerage module, and then we go for sewer pipe 10, you can see the diameter has been updated to 400 mm. Okay, while all this updated diameter happen, you can see the other parameters are still maintained. It will not be affected, such as the PE value, and then for the drain, we can also take a look at the catchment. Okay, as you can see here, the catchment design are still maintained as it is. Okay, the same thing will happen when we try to sync from MiTS into Civil 3D again. Let's say I just add one pipe here as an example. Drain, and then let's say I just add one pipe over here, and then let's say I change the pipe to pipe culvert RC with the diameter of, okay, let's say I change the diameter to 1500 mm. Okay, click OK, and then I go, okay, for synchronization from MiTS into Civil 3D, one of the tips here is that we need to make sure the pipe is part of the running network lah, so that you won't face any verification warning during the sync. So let's say I change it to residential drain, and then I save the project file, and then you can simply go to the Civil 3D, click back on this load from MiTS button, and just click OK directly. You don't have to make further changes to the parameters defined. Okay, now we click OK. Now if we take a look back into the synced entities, you'll be able to see now the newly added drain has been updated as well as part of your Civil 3D network. Okay, and if you take a look at the pipe properties here, you'll be able to see indeed the pipe will have the inner pipe diameter of 1500 mm and it is the concrete pipe. So this basically shows that for the synchronization between MiTS and Civil 3D, the data are being integrated, I would say correctly lah. Alright, so I think that will be all for my demo session. So I'll pass back the session to Mr. Ngu for him to continue with his presentation. Thank you.
As you can see, we have this two-way sync for this MC integrator. So like what we discussed just now, we want to make sure that you will be able to produce Civil 3D drawings even without a BIM modeler. Okay, all right. But I think, yeah, we have to also devote some time to this IFC compatibility lah, okay? Alright, because I also want to show you how we can, in addition to sync to Civil 3D, we can also sync to actually open format IFC and how we can use other BIM software to open the IFC file, yeah? So, let me just do this real quick because this is not the main thing that we want to focus on. Thing here. Let's open up any projects. Okay, let's use this project then. Okay, so this is our project. Okay, so we open up in 3D view. Let me just use this command line. Okay, so I just want to show you how we can actually sync to sync to IFC format and then open it in another BIM software. So let's see. Let me just close all these irrelevant things first, or else you cannot see carefully, alright? This is our 3D view. This is how it looks like, okay? So let's just export it to IFC. IFC, export everything. Oh, okay, here, call it IFC. The date for today is 4th of November. Yeah, 4th of November, I think that's good enough. Exported, complete, okay? So it's now being exported. Let me just show you what it is, how it looks like. Okay. Okay, for those of you who have never seen an IFC file before, I just want to show you how it happens. This is how it looks like. Right, and like what I said just now, you can actually open it up in Notepad. Notepad, where are you? Okay, this guy here. Move already, okay, alright, that's great. See, IFC file is open. Basically, it's in English. You can read. If you can read, then you can write your own parcel. This is the attractiveness of open standard. You see, yeah, we really like this. Okay, but then of course you won't have time to go through this, write a parcel for yourself. So that's why we are going to use BIM software. All right, it's an open source. It's not an open source, but it's a free one. BIM software called BIM Vision. All right, this one you can download yourself. It's a free viewer. I have no idea how they make money, but then here we are. Okay, we can open the thing. Okay, open the file. This is how it looks like. Okay, this is how it looks like. You see. So as you can see, okay, it is sort of similar to what we have. Okay, just compare. Okay, let me just put it back. Move to previous tab. Okay, so let's try to see what we can do side-by-side comparison or not. Okay. Yeah, this is how it looks like here. See? So as you can see, this is our terrain. This is the terrain. And then we want to see the utilities, the network and thing. Okay, this is easier to check. Let me just turn it off to everything. Okay, and then we just also want to turn turn all the terrains off, and this is how it looks like. So as you can see, they are resembling each other. Let me just rotate it. Yeah. So if you want to see, you can check here. Okay, this guy here, for example, just pick one. So it is 18, right? Memorize this 18. This guy also drain 18, right? So this guy drain 6. This guy also drain 6. Yeah. So this is the IFC compatibility part that we are having now. Okay, at this moment of time. All right. So any questions? Okay, no questions. Then we move on. We go back to our civil 3D sync. Okay, right. Where does civil 3D sync? Okay, all right. So now, okay, let's talk about money now. Okay. One thing about this Autodesk product is that the economics is slightly different than what you learn from your mathematics class, right? In mathematics, you always have 1 + 1 = 2, right? But then in Autodesk economics, 1 + 1 can be more than 10 ++, all right? And of course, you know that they are charging you on per name user basis, all right? And there is no perpetual license, all right? No perpetual license, you have to pay annually, all right? And they charge you on per head basis, whether you want to use it or not, whether you are using it or not, doesn't care. If you have one person, that person, then you will charge you 1 license, and you will always tie to that person, all right? So Autodesk has make it actually increasingly hard for you to share license with your colleagues. I'm not too sure whether you are aware of this or not. Yeah, because Autodesk, they are coming up things like 2-factor authentication, stuff like that. All right, so it's going to make it very hard to share licenses. But anyway, when we talk about this Autodesk mathematics, if you buy 2 licenses, can be more than the price of if you buy one AEC collections that comes with 10 software or more. All right, this is the kind of mathematics that Autodesk is playing with. So let me explain to you how the magic works here. All right. So if you go to Autodesk website, you can find that if you just want to buy one single civil 3D, right? The price is around 2,000 USD per name user per person, okay? But if you buy the whole collection, we call it Autodesk AEC collection that comes with civil 3D, Revit, Navisworks, Robot, AutoCAD, pretty much every single software suite in this that is being used by architects, engineers, or contractors. You get it at the price of only 2,500, right? 2,500, right? So the mathematics of Autodesk is that 10 can be more than 1 + 1, right? So you ask, why is this important? Now, why this is important is because of this, all right? I want to bring to you that civil 3D is actually practically free, all right? If you have one AEC license, you already got the civil 3D for free, right? So it's not like you have all your DNI is imposing this kind of financial burden to us, right? Well, I have to buy so many software. No, actually, you only have to buy one software plus, then they give you all the rest already, all right? Then you do not have to use the funds you can use the fund for other things, okay? All right, because why? Like I said, because you will need this AEC license anyway, all right? So for BIM, you need AutoCAD, Navisworks, Revit, InfraWorks, pretty much all of them, yeah? So you buy one license, then you can use it for that one single person, pretty much buffet style lah. Use anything lah. So if you have some BIM model who is a genius, he can do Revit, he can do Navisworks, he can do AutoCAD, he can do everything. Well, you just have to get one license, all right? Okay, then he can do already. And then, like I said, you can use up your funds to buy other things. Yeah, you can, for example, buy another license of MiTS, I would say. Yeah. Okay, so this is what it is. So it's not like, okay, we want to impose a burden on you. Okay, you have to buy an extra civil 3D. It's very heavy on us. Oh, this is not really the case, I would say. Okay, so any questions? especially about the economics part, the money part. Yes.
I'm not asking about the money lah. I'm asking about the software.
Yes.
Because as a consultant, our main problem, what we face is always amendment, always amend.
Yes.
So the drawings we always need to amend. So my question is, because I see we have did extract the output from the MiTS and Civil 3D.
Yes.
So when I look at the cross section, the rock cross section, it actually is I am some sort of like OCD person. I want it to be perfect.
Okay.
So I will edit the output to look nicer.
I see.
So when I edit, I might change the things inside. You know, maybe the level. I think the like 25.49. I want to put it 25.50. You know.
Okay.
So when I do such editing, will it be a problem for Civil 3D and MiTS? Because each time I extract it, I have to edit, do editing. Always have to edit. So is the Civil 3D have the function like I want what output I don't want? Because last time I did extract the water reticulation output from MiTS 2.0. So I did a lot of editing, you know, because the table was a mess. I tried to drag.
Yes,
Took a lot of my time to do the editing.
I see. Okay.
Yeah.
All right. I think yes. Understand. Okay. Good. Actually, I mean, we are again jumping a bit ahead of ourselves. Okay. But let me just jump a bit on myself. What you are saying is that you are editing it, but I think we have to differentiate between two levels of editing. One is that you just want to make the formatting look nice, like for example, moving the tables. Yeah, you are not essentially are not changing the quantity. Right? For this one, Civil 3D and also in MiTS in the future, for Civil 3D, once you actually move the tables, for example, they will stay right there. Yeah, this is the feature of Civil 3D lah. For MiTS, we are actually also implement this. Yeah, so that when you move, for example, the node table in the key plan, in the node thing, then it will stay right there. Yeah, until you delete and re-input again. Right? For Civil 3D, it is staying right there always. Yeah. But another question, another level of question is that just now you said you want to change the IL, for example, from 24.5 to 25.5. But this is, like I said, when you do this, you are actually like introducing a level of inconsistency between what you label and what is the actual level, right? So why are you doing this? I'm just curious.
Because I want my drawing to be, sometimes I want it to be at such level so it looks nicer.
Okay, but why can't you just change the pipe level or change the node or structure level?
Means that I edit it in MiTS. Is it correct?
Oh yes, yeah, edit it in MiTS.
I
Yes.
edit so that when the output come out, it will be the output that I want.
Yes, you edit it in MiTS.
Instead of go and edit the drawing.
Exactly, you
Alright,
edit it in
alright.
MiTS. Yes.
Alright.
Because edit in MiTS you can sit over. Then whatever styling that you change for Civil 3D will still remain. Alright, that's what it is. Any more questions? No more questions, really? Oh, I thought the economics is the most important part because everyone is talking to me that they cannot buy MiTS because they have to buy Civil 3D. Alright, so money apparently is not a problem. That means that Malaysia is doing very well. I'm very happy. Okay, but if you don't have questions, I have questions for myself. Right. Okay, right. So this is the question sometimes I get lah. Okay, you ask me to model in MiTS. I still need MiTS anyway. I still need Civil 3D anyway. Might as well I just model everything in Civil 3D. I don't need MiTS anymore. Anyone is asking this question? Right. I told the software can write to Civil 3D. So why do I still need Civil 3D? If I want Civil 3D, I don't need MiTS anymore. Well, I cannot say whether you want this or that. You have your freedom. Alright, you have your freedom. I cannot force you to use or don't use MiTS. That's your freedom entirely. But then you have to understand that the Civil 3D is not a design software to begin with. For example, it does not have MASMA. It does not have this span guidelines. And then for ATJ, well, ATJ you have to just customize the table yourself, right? For road design, I'm talking about road design. And then for civil, for the kind and field part, the Civil 3D command is not really that easy to use. I'm pretty sure you know. All right. So in a nutshell, it is not a design software. And somehow, as we have discussed with your fellow consultants, there are some features lacking in Civil 3D. Like for example, you cannot adjust the alpha value. You cannot make the surface as close as you want. Yeah. The Civil 3D will just generate a surface based on its liking. You cannot customize it like how you customize it with alpha value, right? So all these shortcomings just shows that Civil 3D is not a design software. It is mostly, like I said, it's mostly a BIM software, right? It's mostly a drafting software, right? Okay, so you don't get all the reports, you don't get all the result validations, you don't know how they come up with the kind of field calculations, right? And and as we have a discussion just now, sometimes you meet with contractor who use Civil 3D, they will just give you this thing. Okay, this is my result. Then when you say, hey, your surface and my surface is not really the same, can you adjust your surface so that we have exactly the same surface? Civil 3D cannot do that. But you can adjust MiTS surface so that it matches exactly like what Civil 3D has, like what I've shown you just now. Alright? So that's what it is. These are the shortcomings of Civil 3D. Not to really trash Civil 3D, but this is just a reality. Okay? And now also, importantly, we have this integrated plugin that will achieve two-way sync, right? Like what we have seen just now. Okay? Right? Another one question that you might ask is that why you can't just reverse engineer the format, the file format. Yeah? You see, interestingly, you can actually use like BriskCAD and all other CADs to open AutoCAD drawing, right? But you cannot do the same for Civil 3D drawing, right? There will be some missing features or missing entities, right? This is because the undertaking of reverse engineering AutoCAD software is done by a consortium called ODA, Open Design Alliance, which consists of all the major CAD players except for Autodesk, of course. So you can actually, they are spending a lot of time into reversing AutoCAD file format. And then because of that, they ran into legal arguments with Autodesk. I'm not too sure whether you are aware of all this backstory or not. Alright? So the fact that we have this BriskCAD and all the whatever CAD comes out is because this consortium took the trouble to actually reverse engineer the AutoCAD drawing, and then they fought a legal battle with Autodesk, and they sort of won. They won the right to actually reverse engineer. Right? This is how you can get all these free alternative CAD out there, or else everyone will be using AutoCAD. No other CADs available. Right? But that's for AutoCAD drawing. Civil 3D wise, not so good. Civil 3D wise, technical difficulties. ODA, they cannot fully do it for some of the entities. Yeah, last time I checked with them, they said, oh, I can only do it for maybe, for example, alignment. Yeah, or pipes and stuff like that. No, we cannot do it. Right? We can't do it. So why you cannot reverse engineer Civil 3D file format? We cannot because no one else can. So Civil 3D is here to stay. This is just a reality. Okay? Okay, and someone may come to you and say, you see, my software also, I don't want to name names. My software very good. If you use my software, then it can automatically produce Civil 3D drawing. Yeah, you don't need Civil 3D, not like MiTS. They say they need Civil 3D software. Mine don't need Civil 3D software. I can immediately reproduce Civil 3D drawings down to every single level. I don't know whether people will say that or not, but I foresee that maybe they will say that. To that, my response is, congratulations. You are really good. Yeah, you are really, really worthy of being the champion of this infrastructure design. But like I mentioned just now, there are difficulties involving in this reverse engineering Civil 3D file. Yeah, that guy is essentially claiming that, oh, they have done something that even ODA cannot. Yeah, so, well, well, it's up to you whether you want to believe in him or not, I would say. Okay, so but I do have questions whether the foundation is actually stable or not, whether he is like, you know, well, selling too much or not, I would say. Yeah, selling too much or not. Yeah, because this is something, this is technical field that not even ODA can do. Yeah, if the ODA, which consists of all the CAD players, cannot do it, then, well, someone else said he can do it, and he is a no-name guy. Well, I just say that I will have some skepticism on it, okay? And most importantly, I would like to say, does it matter? Like I said, civil 3D is practically free, right? So does it matter? Right? Okay? So these are the questions that I would like to ask, and then serve answer. Okay? Any questions so far? Yes?
Saya nak tanya, MiTS MiTS ni, kira dia boleh provide design untuk alignment lah, alignment jalan, parit, piping semua tu kan?
Yes.
Jajaran lah kan, layout lah.
Yep.
Kalau macam untuk jajaran parit, ada culvert semua tu, dia punya size dan capacity tu tak boleh lah ya. Q provided versus Q required semua tak ada lah itu. Faham tak soalan saya?
Okay, I think you are asking whether the MiTS can design for culvert or not based on the catchment or the inflow hydrograph.
Ya, sebab tajuk kita hari ni design infrastructure kan. Saya tertunggu-tunggu cerita tentang design capacity tu.
Okay,
Satu,
okay.
itu satu.
Okay, right, okay, yep.
Satu lagi, tadi masa starting pagi tadi, dia cakap yang MiTS ni dia boleh reverse daripada S-build. Yang itu memang belum sampai ke macam mana? S-build.
Reverse
yang,
S-build.
Yang pagi tadi. Tak ingat yang seorang tadi, yang speaker yang pagi tadi tu, ada cakap yang MiTS ni dia boleh, salah satu kemampuan dia, dia boleh capture daripada S-build lah. Kita boleh start benda tu S-build yang slide pagi tadi tu.
Okay.
Saya ada tulis yang tu. Dan juga satu lagi, untuk kita fokus sehingga peringkat maintenance, yang tu pun ada cerita juga. Ke ada nak cerita sekejap lagi?
Okay, alright. Let me just try to pass your question. First question is that whether Q you can design for Q design and Q provider, that kind of thing. Yes, we can do that. Actually, this is there in the first version of MiTS. Yeah, because basically, right, in the first version, we can already like, okay, say I want to let the program choose a size based on the hydrograph. You can already choose the cover size or the drain size based on the hydrograph or based on the catchment area. Alright, so we did not show that part because that was nothing new lah. It was there since the very beginning, I would say. But anyway, later on, I will actually show more on this. But that is an upgrade version. It's a stormwater analysis one. So later you can stay tuned to hear more. Okay. The second question is about what? Sorry. S-build. Essentially, you are saying that you mean okay. S-build. Okay. If you are talking about S-build, you mean that you have these survey points that you get from the surveyors, and then you can generate a surface profile for that. Yes, that we can do. Yes, that we can do. In fact, my this morning presentation, it was already like the comparison between two S-build profile. I'm not so sure whether that is really what you are asking or not.
Saya faham S-build selepas dibina. Maksudnya macam tadi you tunjuk you punya projek tu tadi, yes, contoh tu kan. Dia punya slope, jalan, whatever, piping. Selepas dibina benda tu jadi macam mana? Is it ikut drawing yang kita design? Biasanya tak sama kan?
Tak sama, yes.
Tak sama. Saya maksudkan S-build yang selepas dibina tu lah. Adakah maksud yang dalam MiTS ni maksud dia berbeza dengan yang saya faham? Tak tahulah.
Okay, but those S-builds are collected from surveyors, right? After collected from surveyors, yeah.
Yeah, from surveyor after construct.
So after construct, so you want it to like go back to the original design surface. Is that what you are saying?
Kan tadi modul ni pagi tadi dalam modul MiTS ni ada cakap boleh capture as-built tu in the early stage. Itu yang saya pun tak faham lah yang pagi tadi punya.
Okay, never mind, we go through the slide again later. Okay, right. Okay, no problem. We go to the slide again later. But for the third question, you are talking about facility management. That's the focal point of BIM software, so that software. But like MiTS, it is mostly a design software. So we are not covering that this facility management yet at this moment of time. Okay, all right. Yeah. So any questions? Oh yes, yeah, please. I think we just take one last question before we move on because I'm afraid that we are late. Okay. Oh. Yes.
You raise your hand.
Yeah. Yes, over there.
Hi, I just want to know, do we really need Civil 3D to convert the MiTS file to Navisworks, or we can convert already to Navisworks?
You mean immediately from MiTS to Navisworks? That's what you are saying. Or currently we cannot do that yet. But then you can convert to Civil 3D and Navisworks contain Civil 3D. There's another way to do though, which is you export MiTS to IFC. Then you can open it up in Navisworks also. Okay? There are ways to do it. Okay? Okay, if you have any more questions, then I think we can handle it later on because I'm afraid we are really running out of time. Okay, so like I said, this is just a recap lah. You model one in MiTS, then export everywhere. Alright, edit in Civil 3D, auto reflect in MiTS, that one you have seen. Fire and forget, right? We want to make sure that you can get away with minimum Civil 3D knowledge, right? With minimum Civil 3D knowledge, right? Alright, so this is the workflow lah, okay? We want to make this MiTS, as far as this infrastructure design is concerned, the one single source of truth, alright? From MiTS, you export the Excel textual report. This is for your own checking or for the authority to check, alright? Right? You do care about the results, right? And this is how you verify your results. You go through the textual report, you check the Excels, you make sure that they all check out, they're all valid, alright? And then you also export the 3D view for presentation, right? You can compare the 3D view in Civil 3D, right, with what we have in MiTS, and then you can see the difference. I don't want to comment much on that. Alright, and also you can do two-way sync with Civil and 3D, or with Civil 3D drawings, right? So for MiTS, you output all these things, then you feed to different party on different drawings or different text files for different purpose. Okay, so MiTS is your single source of truth. This is what we want to make it to be. Okay, alright. So this is where it is coming. Alright, everyone is centered around our desk. But then, where it is going, we hope that we can at least contribute a part, be a kind of alternative solutions for you, all right, in terms of this BIM. If you don't want to use Civil 3D, fine, you have other alternatives. This is in the full spirit, the actual spirit of this BIM thingy, okay? No single party has a monopoly on everything, right? Everyone can share the data, everyone can interact with each other, and this is how it is. Okay, right now, let me just brief you a little bit about this, some of the features, the features that we are doing, okay? Alright, this is how we call the lab features, okay? Not yet in the 3.2 version that we released this morning, but it will be in 3.3, right? So we also want to have this network profile views, alright? Setting to change styles, not cover some table, alright? All these things will be in the future versions, okay? So when you output the Civil 3D, you have all these tables already listed out for you. Later I'll show you how it looks like. Okay, then we also want to have the other way sync for road and earthwork, from corridor to surface sync, alright? Yeah? So the end goal is this, alright? You do all your data in MiTS, alright? and then you sync to Civil 3D, right? That's the idea. That's the idea. Right? Okay. So, alright. So actually, we have an idea coming, a new product that is coming up. Alright. So the idea is that okay, we want to allow the production of decent Civil 3D drawing with very minimum Civil 3D knowledge. This part you already know. But then what is more important is that in the Civil 3D, especially on the gravity catalog, there are some limitations. I'm not too sure whether you are aware or not. Yeah, like for example, you cannot easily add a new size, right? You cannot easily add a new size, right? So and also we really do not have like a default catalogs, right? For this for the market, yeah. Civil 3D has a lot of sizes, but then not all sizes are actually applicable to Malaysia, and not all the sizes are actually in the MS standard. So we want to provide that. So this will be coming in as a new product. It's not under MiTS, but then it will still be done by me and then sold by Brian. Yeah. So it will still be done by me and sold by Brian. So you can check, you can judge for yourself how much of the prestige that MiTS has can be transferred to this particular product. So basically, it's just a small plugin, all right? It's just a small plugin that allows you to do this MS standard catalogs, right? Use that standard catalogs. And for some of the sizes, you can edit it easily, seamlessly, without knowing anything about part size builder and stuff like that, right? And also, it will allow you to actually create cast in situ some size, yeah. Because now you cannot do that in this Civil 3D. So it is only doable in using other ways, like for example doing it in part builders. But then we want to simplify all these things up. Okay, so this is what it is. So this is like a pre-announcement of what we are going to do. Alright, so these are the features of, okay, you will have like the standard catalogs. So just want to let you see, this is the catalog that we collected, yeah. Let's see this one, especially this guy here. Okay, so as you can see, we don't use nearly as many sizes that is available in the this Civil 3D catalogs. So we just collect them out. We go through all the standards and then we collect them out. Okay, and some of them there are no standards, right? Like sums and catch picks, there are no standards, but they are common size. So this one will be in the catalog. And then this particular plugin will allow you to create your own size very easily, all right? No need to use a BIM modeler. You can just type in and then it creates, all right? That's the idea, okay? So all these things, there are other catalog size which I put online, but we will not be going through them because we really do not have time. All right. Anyway, you have these slides after 6 p.m. today, so you can just go in and then you can just read them. All right. Okay. So this is one thing, the standard catalogs. All right. So that everyone is talking using the same catalogs throughout. It's easier also. And also, we want to have better styles. All right. We want to have better styles because the built-in Civil 3D styles are not really well impressive. I'll show you on that later. So we would like to show you what kinds of styles we are actually creating. Okay. All right. Okay, and also we have this adding part size easily, as I mentioned, and also the intelligent mapping, all right? So we want to make sure that you just have to get this one file, then you can auto-magically map between Civil 3D and MiTS pipe types. So it's just seamless, yeah? The end goal, like I said, over and over and over again, is to make sure that you do not have to have a lot of Civil 3D knowledge in order to come out with Civil 3D drawings, all right? Presentable, decent, and acceptable ones. Okay, right. Okay, let me just show you some sneak peek real quick because I think I'm seriously running behind the schedule, right? Oh, I still have 15 minutes to go. I can still take my own sweet time. Then everyone will be going bed late. Okay, right. This is how it looks like. Okay, okay. But this particular, it's called General plugin, will occupy another tab, all right, which I'm not going to show because this is mostly about MiTS. But I just want to show you how it integrates with this MC integrator, all right? How is the before the integration and how is the after the integration? All right. Yeah. Okay. So this is what you have. Let me just open up the drawing. Oh, this is just a very simple drawing. Right. This is just a very simple drawing. Okay. Now we have this sewerage network and also this pressure pipe network. All right. All right. So now. These features are all will be available in MiTS, in MC Integrator, regardless of what. Let's say if you're MC Integrator, this one will all be there. So what happens is that you can actually add gravity table, right? Okay, so you have to use this one to add. Let's real quick. Okay, we do two things at once: the pipe and also the structure of the node. This is how it looks like if you use standard styles. All right. Okay. Then we do for pressure also. Pressure is basically water. Okay. Then, here you go. Click OK. Right. Then you have. Now we do for fittings, which is basically, well, yeah, no appurtenance, something like hydrants. Okay. For this project, there is no hydrants, but then there are fittings. You see, as you can see, they are not really informative, right? These are standard styles. So you have to define your own styles and define your own table things. But then, okay, we don't want you to do all these things. Later we'll show you how. Okay, and then you have these labels. Right, add gravity labels. Okay, this is how it looks like. So in MiTS, this is what you will get also. But then in MiTS, you have this node table, so it's much more presentable. But for this one, this is standard styles. You have to configure yourself. You have to know how to use the styles, the text component, and stuff like that to do the configurations. Okay, and then let's try to do just one more thing. These pressure networks, we are adding the label to the pressure. Okay. The pressure element, right? Okay. Then finally, we are trying to do this profile. Add a profile. Let's put it here. Okay, profile is basically the longitudinal section in Civil 3D. But this is how it looks like. As you can see, the label, the band side here is it's a bit lacking now. Okay. So now, let's say if you use this small plugin, that will provide you with good, usable out-of-box styles. Right? So what happens is that you just have to click on this. Okay, so you start up, you make your drawings, comes with more standard styles. Okay. Alright. Okay, so let's compare the difference. Okay. Here you go to gravity table. Now let's add. We have the new styles coming in, you see. Okay, this pressure. Okay, let's try them first. Okay, okay. Okay, so now let's say if we compare, all right, then you will find that we actually have more things here, all right, more things and it is more understandable and it will be customizable, all right. So here you have this for this structure table, the node. Right on, then you have all these things, but then you can come up with different styles, you see, with all the positions, some positions, ground level, the some hill level, and also the types which are lacking in the default ones, right? So that's the idea. Okay, so let's move on to another thing, gravity label. Okay, so this will be how it looks like. Yeah, so you can see that the current ones, it is more like more, okay, right? It will be more understandable, I would say. Yeah. And the same also goes for pressure network. Yeah. Yeah. So you can compare the difference. Okay. And then we shall allow you to actually change what are the tables that you want to put in here, the fields that you want to put in here. All right, so that you do not have to know how to configure the styles at all from the Civil 3D. You just have to use our command. Something like MiTS interface, you can maybe add this particular field, remove that particular particular field, move this up, move this down, then you can construct all this information that you want. Okay, that's the idea. Alright, finally, for this profile views, let's compare the difference between them. This is how it looks like, you see? Okay, let me just move this in a bit. Okay, so as you can see, we have more views like stations, existing ground level, invert level, and then how that, which is lacking in the standard band sets, I would say. Alright, and this will be configurable, like I said, not by going through Civil 3D internal commands, but going through our these plugin commands, right, which is a stable thing, right? So yeah, so like I said, we are just trying to reduce the workload for BIM modeler, okay? Alright, so any questions so far? Okay. So we still haven't finalized on this thing yet. So when we do, then Brian will let you know, okay? Right? This is a sneak peek of what's going on. Okay, now you see, really let's recap again. Okay, this BIM requirement. Yeah, all the surfaces as you saw just now, we can generate surfaces in Civil 3D. All right, and then we can generate all these object style, label styles, and table styles, like what I showed you just now. All right, in the sneak peek part, you can see all these label style, table styles, and this is exactly what this document means. All right. So basically, the JKR BIM is actually heavily latching on Civil 3D terminology and vocabulary. And now we want to give it all to you. Yeah, for that, we just want to generate everything for you, like through these commands. Then, of course, surface, corridor, these are all Civil 3D things, like what you have seen. Corridor is just 3D road profile. Yeah, there you have seen. Okay. All right, and then you have this road furniture, road markings. This one not Civil 3D objects, but then we're going to put in also. And also the kind of view volume section and cross section. These are all like what you saw just now, like the profiles, the sample lines, groups, and all those things. The one we also demo by Patricia. All right. So here are the recaps of the pipe networks. Yeah. So yeah, that's the thing. Okay, so basically here's a summary table, I would say, okay? Here's a summary table. So if you have this one general plugin only, then what this means is that this is just something like a better styles thing, right? Better catalogs, better styles, right? And it will not help you do your modeling in Civil 3D. Or then you still have to do it manually, or you have to use a MiTS and MC integrator to do it, all right? Okay? It will also not help you do the analysis and design, like what MiTS is doing now. Okay, we give you the analysis results, we give you a design results, right? But then this particular thing is just applying Civil 3D. It's just basically a drafting a BIM modeler tool, right? It is not an analysis and design engine, so it won't do that. Okay, so you still need Civil 3D knowledge for this generator. Okay, all right, you still need, because you need to do all the swap parting, know how to check and stuff like that. Okay, and but it does give you better styles and labeling, okay, all right, and give you this MS catalog and gives you exact dimensions. Yeah, because you can sync to the HMS standard catalogs pipe size, and also for this sum size you can actually create and define on your own. Yeah, right from there. Okay, so if you have this MC integrator, then you will be lacking on these tools. Then you have to do it later on your own, I would say. Okay, get the catalog yourself, curate it yourself, and then do it. Okay, but let's say if you have these things combined together, then pretty much you have everything. So the end goal is to basically producing everything via one shot. That's what our goal is. All right. Any questions on this? All right. So like what Richard O'Brien said, I can remember, we are trying to, oh yes, please.
Hi, good evening.
Yes.
Just want to confirm, this MiTS software, if we have it, can we comply with the BIM requirements of JKR without 3D?
Can we comply with JKR BIM requirement?
Without 3D?
Without 3D.
Or do you need 3D to...
You mean JKR requires 3D or not? Is that your question?
No, civil 3D.
Oh, no, you still need Civil 3D. you still need Civil 3D. But then, like I mentioned just now, Civil 3D is free, right? Yeah, it's free because no matter what, you will need other modules in the AEC collections, right? Like Revit, like Navisworks, this one you still need. So the moment you get these two software, the Civil 3D comes as free to you already. That was my slide, that was my point just now. Here. That was my point just now, right? Civil 3D is practically free, right? Because you will need AEC collection no matter what, right? You will need Revit, you will need this Navisworks, you will need AutoCAD and stuff like that, right? This is not on the infra side, this is on the structure side, right? So if you say, oh, I want to do away with Civil 3D, do away with Civil 3D, then it's not sufficient that you do away with Civil 3D only. You need to do away with all of the Autodesk AEC collection, including Navisworks and Revit and stuff like that, right? So yeah, so this is what I said. Yeah. Any questions? I guess we have time, so yeah, I can field a few more questions if you want to. Any questions? Okay. If no questions, then let me just continue. Okay, so as far as this BIM evolution is concerned, I think a lot of time it is being driven by software vendors, by these practitioners, by consulting engineers. Yeah, so we would like to actually involve in the conversation. Actually, we are already involving in the conversation. All right, this is how we involve in it. All right, we try to see what are the things that are needed and what are the things that we can put in, and we are trying to see what are the things that we can create in order to have more this kind of BIM sharing and things like that. Okay. All right. So yeah. So okay, this is, let's say if you get a JKR project, then if you want to consult us on what does that mean, right? What does that mean? Or what is all this table style, label style means, and so on and so forth? Well, we're actually free to go through. We're actually very happy to go through with you. Yeah, because we also need those ideas to improve our software features. In fact, all the features that you've seen is actually coming from someone who is kind enough to share all these documents with us. So we know exactly what JKR wants. And then we can actually create them. And then we can actually try to fulfill the requirement. Right? Okay, so yeah. So if you have any questions, you can always reach us out. Right, so these are all the references. Actually, I'm done with my presentation. How many minutes do I have? All right, a few more minutes so I can take one or two questions. Okay, so if no more questions, then I'll just pass the time to MC.